Okay, so imagine you're working on a critical task, maybe approving a loan or guiding an autonomous vehicle. You're part of a team, but your teammate isn't human. It's an AI. Now here's the wild part. Even if that AI does absolutely nothing, your brain might unconsciously decide you're more responsible for the outcome while your conscious self is busy thinking, Bobby could have done it.
It's an absolutely fascinating paradox, isn't it? The brain, in its infinite wisdom, seems to be doing two contradictory things at once, all because it believes an AI could act. It's like our primal social cognition kicking in, but adapted for a silicon partner.
So my conscious mind is offloading responsibility, thinking someone else could handle it, while my unconscious is putting a big, bold, made by me tag on my actions. That split, that internal contradiction, is what we're calling the Bobby effect.
Exactly. And it's not just a cognitive quirk. It has profound implications for how we design and implement AI systems in high-stakes environments. It's about accountability and our fundamental sense of agency in a world increasingly shared with intelligent machines.
That opening hook really lays out the core paradox. This isn't just a philosophical debate about AI, it's about how our minds are literally wired, or perhaps rewired, when we interact with these systems. And it all starts with a concept from social psychology that's been around for decades, right? The classic bystander effect.
Absolutely. To truly understand the Bobby effect, we have to go back to its roots, the bystander effect. It's a phenomenon that's become almost legendary in social psychology, largely sparked by a tragic event back in 1964, the murder of Kitty Genovese.
That's the one where initial reports claimed many people witnessed the attack but didn't intervene. It became this stark illustration of collective inaction.
Precisely. While those initial reports were later found to be somewhat exaggerated in terms of the number of direct witnesses and their inaction, the event undeniably galvanized researchers. Bibb Latané and John Darley were two of the pioneers who really dug into it, and their experiments in the late 60s provided the empirical foundation for what we now know as the bystander effect.
I remember reading about their classic experiment. Participants in a room hearing someone in another room simulating an epileptic seizure, and the key variable was whether they thought they were alone or if others were present.
Exactly. The results were stark. If you thought you were the only one who could help, a whopping 85% of participants stepped up. But if you believed others were also present, that number plummeted to just 31%. It's a powerful demonstration of how the presence of others dilutes our individual sense of responsibility.
So why does that happen? What are the mechanisms Latané and Darley identified?
They pinpointed two main drivers. First, diffusion of responsibility. This is the idea that when multiple people are around, the personal pressure to act is spread out. Everyone assumes, someone else will handle it. The more bystanders, the less responsibility any single person feels. It's a very rational, almost logical mental shortcut.
And the second one?
That's social influence, sometimes called pluralistic ignorance. In ambiguous situations, we tend to look to others for cues on how to behave. If everyone else is doing nothing, it signals that perhaps no action is needed, even if privately you're feeling concerned. Think of a crowded street. If no one else is reacting to something unusual, you're less likely to react yourself. You assume they know something you don't, or that it's not a real emergency.
So these are well-established human social dynamics, but the leap from a human bystander to an AI bystander, that's where this new research by Lee, Burke, and Bayliss comes in, right? It asks, does this diffusion of responsibility still apply when the other person isn't a person at all, but a machine?
That's precisely the central question. As AI transitions from being a mere tool to an active, often intelligent collaborator in various fields, understanding how these partnerships alter our fundamental sense of control and accountability becomes absolutely critical. This isn't just a theoretical exercise anymore, it's a real-world necessity.
And that's where Bobby enters the stage.
Indeed. The researchers from the University of East Anglia developed a really clever experimental design to test this specific question. They wanted to isolate the sense of agency, that feeling of being the cause of events in the world, of initiating and controlling actions.
So how did they do it? What was the setup?
They had 123 participants play a simple online game. The task was straightforward. Press a key to stop an expanding shape on the screen before it turned red. The goal was to be quick and precise.
Okay, simple enough. And then the conditions?
Yes, this is where it gets interesting. Participants were randomly assigned to one of two conditions. In the alone condition, they were told they were solely responsible for stopping the shape. Clear cut.
And the other condition, the Bobby condition?
In the Bobby or together condition, participants were introduced to a virtual partner named Bobby, represented by a smiling avatar. They were explicitly told that Bobby was another online participant who could also press a key to stop the shape. Crucially, though, Bobby never actually acted. Any successful outcome was always, unequivocally, the result of the human participant's action.
Wait, so Bobby was a ghost in the machine, just the presence of potential actor, but never actually doing anything. That's brilliant. It isolates the expectation of shared responsibility.
Exactly. And this is where the elegance of their methodology really shines. They weren't just asking people, how do you feel? They measured this sense of agency in two distinct ways. This distinction is absolutely fundamental to their paradoxical findings.
Let's unpack that. What's the difference between explicit and implicit agency in this context?
Explicit agency is what we might call the conscious feeling of control. It's your self-reported judgment. After each block of trials, participants were directly asked to rate their level of control over the outcomes on a numerical scale. It's your conscious, reflective assessment of your own influence. Yes, I was in charge, or no, I didn't feel entirely responsible.
So that's the straightforward survey data, but the implicit measure, that's where it gets really clever, right?
That's right. For implicit agency, they used something called the temporal binding effect, also known as intentional binding. This is a subtle perceptual illusion. Think of it like this. If you voluntarily press a light switch and the light immediately comes on, your brain actually compresses the perceived time between your action and the outcome. You perceive your action happening slightly later and the light coming on slightly earlier than they actually did.
So your brain sort of pulls the action and the outcome closer together in your perception.
Precisely. It's an unconscious mechanism that helps link cause and effect. And the strength of this binding, how much that perceived time interval shrinks, is considered a reliable, unconscious marker of how strongly you feel you caused that outcome.
That's fascinating. So how did they measure that in the experiment?
After the participant successfully stopped the shape, a sound was played 250 milliseconds later. Participants were then asked to estimate the duration of the interval between their key press and that sound. If they estimated a shorter interval than 250 milliseconds, it meant the temporal binding effect was strong, indicating a higher implicit sense of agency. It's a truly ingenious way to tap into those pre-reflective, automatic cognitive processes.
So they had a conscious measure, asking people directly, and an unconscious measure, based on this subtle temporal distortion. This dual measurement approach is really what allows them to uncover the nuanced Bobby effect.
Exactly. It's what moves the study beyond simple introspection and into the deeper, automatic cognitive machinery that underpins our sense of self in the world. And the results are, as you teased at the beginning, quite paradoxical.
So let's get to those results. What happened to explicit agency when Bobby was present?
When participants were asked directly how much control they felt, those in the Bobby condition reported a significantly lower sense of control compared to those who worked alone. This is the direct parallel to the classic bystander effect.
So their conscious mind was diffusing responsibility. Bobby could have acted, so I'm not entirely on the hook. That makes intuitive sense, connecting directly to Latani and Darley's work.
Exactly. The conscious, deliberative part of the brain registered the presence of another potential actor and immediately offloaded some of that personal responsibility. It's a cognitive shortcut. I don't have to be 100% vigilant because Bobby might get it.
But then the implicit agency data, that's where the paradox truly emerges, right?
That's where it flips entirely. The temporal binding data showed the exact opposite pattern. When working alongside Bobby, participants exhibited a stronger temporal binding effect. They perceived the time between their key press and the subsequent tone as being shorter than when they worked alone.
So their unconscious brain was saying, hey, I did that, even as their conscious brain was saying, "We did that," or "Bobby could have." That's truly wild.
It is. This stronger binding, according to the established literature, implies a heightened unconscious sense of agency. While the conscious mind was busy sharing the blame, the automatic parts of the brain were working harder to tag the action outcome link as mine.
This leads to an important question, though. Was this simply because they thought someone was watching them? A sort of social presence effect, making them more aware of their own actions?
That's a crucial point, and the researchers anticipated it. They conducted a brilliant control experiment to rule that out. They ran a second experiment with a new group of participants, but with a critical modification to the Bobby condition.
What was the modification?
In this version, the observer Bobby condition, participants were told Bobby was present and would be watching their performance, but that Bobby absolutely could not act to stop the shape. So Bobby was a social presence, but not a co-agent.
And what did that reveal?
The results were definitive. When Bobby was merely an observer, the effects on both explicit and implicit agency disappeared. Participants' sense of control, both conscious and unconscious, was the same as when they were working alone. This proves that the key trigger for the Bobby effect is not just being observed, but the AI's perceived potential to act as a collaborator. It's the AI's status as a co-agent that fundamentally alters our internal sense of agency.
So it's not simply that I'm being watched, it's that I'm being watched by someone who could do what I'm doing. That's a subtle but critical distinction.
Exactly. It's the perceived shared responsibility and potential for action that causes this cognitive split. The implications of this split are where the real significance of the study lies. Why would our brains do this? Why this seemingly contradictory response?
That's the million-dollar question. It feels almost counterintuitive for the brain to be pulling in two different directions like that.
It does, but Anglais and her colleagues offer a really compelling explanation. They propose that this dual response is actually a very smart strategy for navigating a collaborative world, even one with AI.
So let's take the conscious mind first. Why does it diffuse responsibility?
The explicit conscious system, they argue, is concerned with higher-level cognition, things like social reasoning, responsibility attribution, and managing cognitive load. When a capable partner, even an AI, is introduced, this system logically concludes that responsibility is shared. It's an efficient cognitive shortcut. It offloads some of the mental burden and the pressure to perform perfectly. It's your mind saying, Bobby might get it, so I don't have to be 100% vigilant, I can relax a bit.
That makes sense. It's a way to conserve mental energy, or perhaps reduce stress if you don't feel entirely responsible.
But then the unconscious side, the implicit agency, goes the other way. Why does it sharpen its sense of control?
This is where the brain's priority for credit assignment comes in. The implicit automatic motor sensory system has a different goal. To learn effectively, to adapt our actions for future success, the brain needs to know with absolute certainty which outcomes were caused by its own actions versus the actions of others.
So it's trying to maintain a clear self-other distinction. If Bobby could have pressed the button and I press the button, how does my brain know who gets the credit or the blame?
Precisely. To prevent this ambiguity, the brain enhances the processes that link self-generated actions to their sensory consequences. That stronger temporal binding effect is a manifestation of this sharpened self-other distinction. It's the brain's low-level automatic way of putting a clearer made-by-me tag on the action-outcome event.
So it's almost like a survival mechanism to accurately attribute learning, to know what you did versus what someone else did.
Exactly. As Lay herself put it, we have an implicit system that is enhanced to help us distinguish ourselves and our actions from those made by others.
It ensures that when you succeed or fail, your brain correctly updates its internal models about your own efficacy, not Bobby's. It's an unconscious defense against cognitive confusion in a collaborative setting.
So, our sense of agency isn't a single monolithic thing. It's this complex interplay between conscious beliefs and unconscious processing, and AI partners are causing them to diverge. That's a truly profound insight.
It really is, and it underscores that as we integrate AI into more aspects of our lives, especially professional ones, we're not just adding a tool, we're fundamentally altering our cognitive landscape in ways we're only beginning to grasp.
And this isn't just a lab curiosity. This Bobby effect has serious real-world implications, particularly when we talk about things like automation bias and accountability.
Oh, absolutely. The conscious reduction in the sense of agency, that feeling of Bobby could have done it, is a direct pathway to automation bias. This is a well-documented human tendency to over-rely on and favor the suggestions or actions of automated systems, sometimes even overriding our own judgment.
So if I consciously feel less responsible, I might be less vigilant, less likely to double-check the AI's output?
Exactly. And that leads to two types of errors. Errors of commission, where you follow an incorrect suggestion from the AI, like a GPS routing you into a dead end or worse. And errors of omission, where you fail to act because the automated system didn't prompt you, like a pilot missing a critical warning because an alarm didn't sound. This learned carelessness can have catastrophic consequences in high-stakes fields like aviation or medicine.
So the Bobby effect essentially makes us more susceptible to automation bias because our conscious mind is already in that shared responsibility mindset.
Precisely. And perhaps even more concerning is the issue of accountability diffusion. In any organization, when a decision or an outcome is the product of a human AI team and humans are consciously feeling less responsible, it becomes incredibly difficult to assign blame when things inevitably go wrong.
This is where everyone can point fingers elsewhere. The human operator says, I was just following the system. The system's designers say the human made the final call. And the AI, of course, can't be held accountable.
That's the problem, and it leads directly to what Madeline Claire Eilish calls moral crumple zones. Think of a car's crumple zone. It's designed to absorb the force of an impact to protect the occupant. In socio-technical systems, the moral crumple zone is often the human operator. They're positioned to absorb the legal and moral blame for a system's failure, even if they had limited control or understanding of the AI's inner workings.
So the human takes the fall, while the AI system and its creators are shielded. That's a truly troubling thought.
That's the problem. Imagine a loan officer using an AI model for applications. They might consciously defer to the AI's recommendation, feeling less personal responsibility. If that model is later found to be biased, the bank might claim the human officers made the final decisions, while those officers felt they were merely executing the AI's directives. Accountability becomes dangerously ambiguous.
This really highlights the urgent need to design systems and organizational structures that actively counteract this diffusion of responsibility. We need clear lines of ownership, meaningful human oversight, and a rejection of the idea that AI can simply be a scapegoat.
Absolutely. The Bobby effect is a powerful reminder that our minds treat capable AI not as simple inanimate tools, but as social actors, and that changes everything about our internal cognitive landscape.
So, to synthesize this complex but crucial research, what are the absolute key takeaways listeners should walk away with?
First, the classic psychological principle of the bystander effect, where responsibility diffuses among multiple actors, extends directly to our interactions with AI. When we perceive an AI as capable of acting, our conscious sense of responsibility decreases.
And second, that's where the paradox comes in. Our brains have a split reaction. While our conscious agency goes down, our unconscious automatic tracking of our own actions and outcomes actually gets stronger.
Precisely. Third, this isn't just about being observed. The effect is specifically triggered by the AI's perceived potential to act as a collaborator, not just its mere presence.
And that fourth point, the why? The brand strategy is to have the conscious mind offload responsibility for cognitive efficiency, while the unconscious brain sharpens its self-other distinction for accurate credit assignment and learning.
Finally, these findings aren't theoretical. They have profound real-world consequences, exacerbating automation bias and creating moral crumple zones, where accountability for AI-assisted failures becomes dangerously ambiguous.
It really reframes how we should think about human-AI collaboration. So, to leave our listeners with a couple of thought-provoking questions, how can we design AI systems and workplace cultures that leverage the benefits of AI without inadvertently eroding our fundamental sense of personal responsibility and accountability?
And perhaps even deeper, what are the long-term cognitive and psychological impacts of working with AI if our brains are constantly making these subtle, unconscious adjustments to our sense of self and agency?